Okay, this video is on angle types and angle proofs. Part of the 2.5 work. You should take your stuff out, take notes with me, and we'll go through the lesson. So first of all, there is a big picture there, and it wants you to identify some different types of angles. So we have right, vertical, complementary, and supplementary, so I'm going to go ahead and do that. So I don't have any marks on here, but there appears to be a whole bunch of right angles, so I'm going to start by listing those. So I see a right angle here, AGC is a right angle. That one appears right. This one, CGE, appears to be a right angle. So I got those two. And then there looks like there's one, and this angle, if I added 4 and 5 together, and if I added 2 and 3 together, looks like I would also get right angles there. So I'm going to put angle BGD is a right angle, and angle DG, and that low point right there is F. Angle DGF also appears to be a right angle. And that's just by visually looking at them. There's no markings on them or anything that says the right angles, but if I had to pick out the right angles, those would be it. Vertical angles make an X. They are X angles. So do I see, well, the only X I see is right here. So these two angles in those two spots would be the vertical. So I'm going to put angle 1 and angle 5 are vertical. And I could have even added that little congruency sign in there because they definitely are congruent to each other. And then I see another one here, angle 6. Well, if I had this angle here, that really makes an X with all of this over here. This whole one in this whole spot and that whole angle there. So I'm going to write this one a little different way. Angle 6 and 2, 3, and 4, that one and that whole chunk would go together. So I'm going to put angle 6 is congruent to angle 2 plus 3 plus 4. Just a different way of writing it. Complementary means they add to 90. So I get two angles. A complement is the right thing to do. So we have a right angle here. These two angles here would be complementary. A right angle here, we have 4 and 5 are complementary. A right angle here, 3 and 4 are complementary. So really it's any two angles that are complementary. I'm going to put the easiest one, angle 1 plus angle 2 equals 90. We would probably actually say 1 and 2 are complementary and then say 1 and 2 are 90. I just wrote it like this. Supplementary are two angles that add to 180. Remember, if I'm taking supplements, I'm getting strong, supplementary strong, and then I can bench press 180. So supplementary adds to 180 degrees. So linear pair, these two are pretty much the same. So I'm going to put 180 there. Linear pairs are supplementary. Supplementary aren't necessarily linear pairs. Supplementary don't have to be attached. Linear pairs have to be attached. So I'm going to pick a set of angles out over here that kind of goes with these two. What I'm going to pick is I'm going to pick this big angle 6 right here and this little angle 5 right here. Those two fall in a line. They are next to each other. They are linear pairs. So I'm going to put angle 5 plus angle 6 are going to add up to 180. And again, I could probably say, well, 5 and 6 are supplementary. Then I should say the measure of 5 plus the measure of angle 6 equals 180. Just kind of rolling that all into one idea right there. These angles are going to get involved in the next few proofs that we do here. So, angle proofs. Okay. So very similar to algebraic proofs, very similar to segment proofs. What I have to do is I have to solve it out for x. And while I solve it out for x, I'm going to provide reasons and statements and everything else like that. Now, unlike some of the problems where we started with the given and the prove and then we drew the picture, here I'm giving you a picture and I'm going to go back to the given and prove and then write everything. Okay? So here's the way it works. Given. Well, obviously I'm given the picture. What's specifically off the picture that I'm given is this angle right here is 3 times 6x plus 7, and this angle right here is 10x plus 45. So my given, I'm going to write those things angle AEC is equal to 3 times 6x plus 7. The other one, angle BED is equal to 10x plus 45. And like I said, rather than picture gives me, or given gives me picture, we're going picture gives me the given, and I can actually go back and forth on this. So what am I trying to prove? Well, there is no proof, but there's an x. So I'm assuming I'm going to solve for x. So I'm gonna make a little bit of a leap in logic. I'm just gonna say, yeah, I'm gonna prove, I'm gonna solve for x and justify. And justify would mean I'm going to make a t-type proof. I'm gonna do all the solving and find out what the answer is. Okay, so now that I have those two things, I'm gonna go ahead and write my t-type proof. All right, statements go over here. Reasons go over here. My first statement is, well, here's the problem. Angle AEC is equal to 3 times 6x plus 7, and angle BED is equal to 10x plus 45. I'm gonna write one other thing that I was really given. Really what I was given the picture. So I'm gonna write also given picture, because I am gonna work off of that picture. And step number 1, all of these things are given. And I don't wanna write given 3 times, so I just wrote the G big, given, it's all given. There we go. Number two, okay, so this is really your one geometry step. So I'm gonna look at the picture, and I'm gonna see if there's anything maybe that adds up to 180, maybe if there's any 90 degrees, maybe if there's congruent angles, just somehow, somewhere, there's gonna be something off the picture that's gonna lead me to solving the equation. And I notice right here, I got this x here. You should know something about angles that form an x. So I'm gonna write down that angle AEC is congruent to, so this angle right here is congruent to the one that it forms the x with. So I'm gonna put angle BED. And the reason I could say those two angles were congruent is because they are vertical angles. And my geometric rule here is vertical angles are congruent or equal. Their measures are equal, or the actual physical figures are congruent. So I just put they're congruent. And you know, some things will actually make you go and now say, well, since they're congruent, their measures are equal, and since their measures are equal, I can put these, I can move things around. I don't really go through that. I go ahead right now and I'm just gonna take AEC, which is this angle right here, and I'm gonna write down what it is. So I'm taking that out and I'm plugging that in. So step number 3, I'm gonna get 3 parentheses 6x plus 7. So that shoved in for that. And then BED, the 10x plus 45, shoved in for that. So I'm gonna put equals 10x plus 45. And when I take something out and I put a new thing in for it, that's called substitution. I could put substitution property of equality. Now, here's your challenge. Here's what I want you to do. I want you to hit pause right now, and what you're gonna do is you're gonna try to solve that out, both sides, come up with an X answer, see what you get, and after you unpause it, see if that's what I got in the end. Okay, assuming you did that now, so step number 4, what I would have done on the next step is I would have used distribution. So I would say 18x plus 21 plus 21 equals 10x plus 45. 4, I would have written distribution or distributive property of equality, and it is fine to go ahead and abbreviate. Step number 5, I'm gonna write 8x plus 21 equals 45. What I did was I minus the 10x over. You actually could have had this down a couple steps, but I'm gonna minus the 10x over in my head. So step number 5, what I used was subtraction, property, quality. Number 6, 8x is now equal to, well, really what I'd be doing is I'd subtract the 21, so that's 24 here. So step number 6, to get from there to there, I did that subtraction. So again, it looks like I used subtraction, property, equality. And then my last step, step number 7, I got x is equal to 3. And on step 7, I used the division, property, equality. So that's kind of a example of a proof here where we actually took a geometric picture, came up with our given and our statements, and did the whole thing out in one big giant proof. All right, I got one more proof. Okay, again, what I would like you to try here, and try to hold yourself accountable to doing this. I know it's on a video, it's really easy to fast forward through, but I want you to press pause here and I want you to see if you can write the given and what we're trying to prove, and very similar to what was above it. So go ahead and do that now. Okay, assuming that you've done that, what I would have put up here on the given, I would have said that angle ADB is equal to 15W. That's given to me in the picture. I would have put let's try that again. I would have put angle BDC is 5 parentheses W minus 4. And also given the picture, given the picture. So I don't know, maybe you put something else about it. I would have started with that. And again, what I'm trying to prove is I'm trying to prove that I can find W and justify the steps. Find W and justify your reasoning. All right, so got my T. Got a rather big T. All right, so statements here. Reasons here. And I'm going to start with the given. I'm going to start with these things, and I'm literally just recopying. You always take those and recopy them for those spots. So I'm going to put angle ADB is equal to 15W. I have angle BDC is equal to 5W minus 4. And I'm also given the picture. Given the picture. Given. All right. From here, I gotta look at my picture and I gotta see, is there some type of relationship up here that allows me to write an equation or come up with a geometric rule, or do I see a word that says complementary or something up here? And what I notice is I have two angles on a line here. Man, I know those two things add up to 180, and I gotta write that in, and that they're 180. So I'm gonna do that. Step number 2, I'm gonna write that angle ADC, and I could put, if you ever like look at a book, you know what, I think I'm gonna do that just so you're used to it. Books and Canvas quizzes and stuff like that, I sometimes drop, there's a little M that they put in here. Sometimes I'll put like M, if you ever see that, of angle ADB plus little m. So there might be little m's here. Put M angle BDC. So I said measure of angle ADB DB plus measure angle BDC. Those two angles right there, they're gonna add up to 180 degrees. And there's a rule that says that, and depending on what book publisher you have, it might say linear pair rule or linear pair postulate or some linear pair axiom. It really depends on your book publisher. Basically, the reason I was able to write this is because they are linear pair. So I get rid of all those fancy words and I just write linear pairs add to 180 degrees. I think in this book it's actually called the linear pair postulate. So if you see linear pair postulate, that's what they're trying to tell you. You could write linear pair postulate there. Heck, I don't care if you write linear pair, I heart linear pairs, linear pair smiley face. Doesn't matter to me. It's gotta have something about linear pairs in it because that's what you have there. That's why you're able to write that statement. Number 3, my hope now would be that you could use this and you could follow along what we did on the last proof and you could do it even from here. Right? Maybe you can't, maybe you can. Try to hit pause, see how far you can get, restart the video, and let's see where you're at. Okay, hopefully you've done that. All right, so I'm gonna substitute now. I'm gonna take 15W and plug it in for the measure of angle ADB. This literally says the measure of angle ADB plus the measure of angle BDC is equal to 180. Well, I'm gonna substitute in. I'm gonna go 15W plus 5W minus 4s adds up to 180 degrees. Okay, and the reason I was able to go from all of this to here was because I took that out and I took the 15W, took it, so it's like I'm taking these two and I'm taking that out and I'm plugging that in, and whenever you take something out and plug something in, it's called substitution. So I'm gonna write substitution, and then you should have gone 15W plus 5W minus 20 equals 180, and on that one I used distribution, and these are both properties of equality, They're properties of equality because there's an equal sign there. Step number 5, I'm gonna do this. 20W minus 20 equals 180. And step number 5, what I've done there is I took those two and I shoved them together, or I combined like terms. CLT. Step number 6, I got 20W equals 200. Step number 6, what I did from there to there was I added 20. So that's the addition property of equality. And then step number 7, I got my W value is equal to 10. And on step number 7, I used division property of equality. All right. That's the notes from chapter 2.5. What you should be ready to do now is you should be ready to go on and take those Canvas quizzes. And on the Canvas quizzes, what you're gonna see is you're gonna see a lot of these things filled out with maybe a blank here. Or maybe they have a bunch filled out and they want to know how you went from here to here, so they left a blank here. And your job is to either grab the pull down menu or choose the multiple choice answer that would correctly fill in the blank to go ahead and complete the proof. So should be ready for chapter 2.5 right now. Have fun and go to it.